1 minute ago, the most powerful telescope humanity has ever built pointed itself at something that should not exist. Not a planet, not a star, a visitor, an object that did not come from our solar system, that is not bound to our sun, and that scientists say is unlike anything ever recorded in the history of astronomy. And when the James Webb Space Telescope finally turned its instruments toward it, what came back was strange enough that researchers are still arguing about what it actually means. This is the story of 3I Atlas, the third interstellar object ever confirmed to pass through our solar system, and the warning buried inside the data James Webb sent home. Stick around, because by the end of this video, you'll understand exactly why scientists dropped everything, interrupted the telescope's planned schedule, and rushed to observe this object before it vanished back into deep space forever. Let's start with the basics, because this story only gets stranger once you understand what makes an interstellar object so different from everything else we normally see in the night sky. Every comet or asteroid you've ever heard of, Halley's Comet, the asteroid belt, even the icy bodies way out past Pluto, all of them belong to our solar system. They orbit the sun. They were born here out of the same swirling disk of gas and dust that formed the planets 4.5 billion years ago. An interstellar object is different. It was born around a different star, in a different solar system entirely, possibly light years away, and possibly billions of years ago. It was flung out into the galaxy long before humans existed. And it has been drifting through the emptiness of space ever since, until, by pure chance, its path crossed ours. Only 3 of these objects have ever been confirmed. The first was Oumuamua in 2017, a strange, elongated object that tumbled through our solar system and left scientists debating its shape and origin for years. The second was Comet Borisov in 2019, which behaved more like a typical comet, but still carried the unmistakable signature of an outsider. And now the third, discovered by the Atlas Survey Telescope, a network specifically built to watch the skies for dangerous incoming objects. This new visitor was given the name 3I Atlas, the I standing for interstellar. From the moment it was spotted, astronomers knew this one was different. Its orbit wasn't a closed loop like a normal comet, circling the sun forever. It was hyperbolic, meaning it was only ever passing through on a one-way trip that started somewhere else in the galaxy and would end somewhere else entirely, long after it leaves our solar system behind for good. Once astronomers traced its path backward, the picture became even more remarkable. This object had been traveling through interstellar space for an unknown stretch of time, completely untouched by any sun, before physics finally pulled it into a curve that brought it briefly into our neighborhood. If you're new to this channel, we cover space stories exactly like this one every single week. So go ahead and hit that subscribe button now, because this next part is where the real mystery begins. As 3I Atlas made its approach toward the sun, astronomers pointed almost every major telescope available at it. The Hubble Space Telescope captured images that helped estimate its size. The Very Large Telescope in Chile gathered additional data. Even the Psyche spacecraft and the Lucy spacecraft, both already out in space on unrelated missions, managed to catch glimpses of it in passing. But it was the James Webb Space Telescope that delivered the results nobody expected. In August of 2025, using its near-infrared spectrograph instrument, James Webb observed the comet and detected something scientists were not fully prepared for. As the object warmed up on its approach to the sun, ice inside it began turning directly into gas, forming a cloudy halo around the object known as a coma. Webb's instruments broke that coma down into its chemical components, and the results revealed carbon dioxide, water, water ice, carbon monoxide, and a rare foul-smelling gas called carbonyl sulfide. None of those chemicals alone would have been shocking. Comets are essentially dirty snowballs, and finding water and carbon dioxide is completely normal. What stunned researchers was the ratio. The amount of carbon dioxide compared to water in this object's coma was the highest ever recorded in any comet, from our solar system or otherwise. To put it plainly, this object is carrying an unusually massive amount of carbon dioxide relative to everything else inside it, and scientists are still trying to understand exactly why. One leading theory is almost hard to comprehend. Researchers suggest the ice inside 3I Atlas may have originally formed under conditions far more extreme than anything found in our own solar system, possibly exposed to intense radiation over unimaginable stretches of time in the outer reaches of a completely different star system, long before it was ever ejected into the galaxy to begin its journey toward us. If that theory holds, this object isn't just a visitor, it's a physical fossil, carrying frozen chemical evidence from the birth of another solar system. One humanity has never seen and likely never will see directly, sitting right there in a spectrograph reading captured by a telescope orbiting our own sun. Then, in December of 2025, after the comet had swung around the sun and begun its journey back out toward interstellar space, James Webb took another look. This time, using its mid-infrared instrument, It captured something that had never been recorded before in any interstellar object. A full mid-infrared chemical fingerprint, detected across 2 separate observation dates as the comet made its exit. That data confirmed the presence of methane, adding yet another chemical signature to an already unusual profile and cementing something astronomers had started to suspect all along. This comet does not behave like anything native to our own solar system. Now here's where the story took a turn that spread far beyond scientific journals and into headlines around the world. As word of these strange readings spread, some outlets and commentators began raising a different kind of question entirely. Was this simply an unusual comet? Or was something about its path, its brightness, and its behavior worth watching more closely for other reasons? Reports circulated describing unpredictable brightness changes and course adjustments that seemed to defy easy explanation. And for a brief period, public conversation shifted from pure curiosity to genuine concern about what exactly was moving through our solar system. To be clear about where the actual science landed, NASA has been direct on this point. The agency has stated plainly that Comet 3I Atlas poses no threat to Earth. Its trajectory has been tracked continuously by multiple observatories, and its hyperbolic path means it was never going to come anywhere near a collision course with our planet. The real story was never about danger. It was about opportunity, a once-in-a-lifetime chance to study raw material from another star system up close, using the most advanced telescope humanity has ever built. And that's arguably the more incredible story anyway, because whatever caused that unusual chemistry, whatever conditions shaped this object long before it ever encountered our sun, it represents a kind of direct sample from outside our own cosmic neighborhood, delivered to our doorstep without us having to travel a single mile to get it. Scientists studying 3I Atlas have said this data offers a genuinely rare opportunity to compare conditions in a distant alien planetary system to what we already know about the early formation of our own solar system, 4.5 billion years ago. Think about what that actually means. Every planet, moon, asteroid, and comet in our solar system formed from the same disk of material swirling around our young sun. We have spent decades studying that material to understand our own origins. But an interstellar object gives scientists a comparison point from an entirely different system built around a different star, shaped by different conditions, possibly formed under a completely different set of rules. It's the closest thing to receiving a care package from another solar system, and it happened to fly close enough for our best instruments to actually read it. This is also exactly why astronomers moved so quickly once 3I Atlas was discovered. Objects like this do not wait around. They are not captured into orbit around our sun the way planets are. They pass through once on a trajectory that will never bring them back, and then they are gone from our solar system permanently, continuing on their journey into the depths of interstellar space, possibly for millions or billions of years, until they encounter another star system entirely. Every single hour that telescopes had access to 3I Atlas was borrowed time. Missed the window, and that chemical fingerprint, that fossil record from another solar system, is gone forever. That urgency is part of why James Webb's schedule was interrupted to prioritize these observations. The telescope is in extraordinarily high demand, booked out for planned observations of galaxies, exoplanets, and star-forming regions all across the universe. Pulling its focus toward a fast-moving, temporary visitor required real coordination and real sacrifice, using observing time that other researchers had been waiting years to secure. The fact that scientists chose to make that trade tells you exactly how significant they considered this opportunity to be. So where does that leave us now, in the middle of 2026, months after those initial readings first stunned the research community? Papers analyzing the JWST data continue to be published. Researchers are still working through what the extreme carbon dioxide ratio actually reveals about the conditions in which this object originally formed. And astronomers around the world continue debating exactly how unusual or how ordinary this kind of interstellar chemistry might turn out to be once we eventually detect a 4th, a 5th, and a 6th interstellar visitor in the years ahead. Because, make no mistake, this will happen again. With modern survey telescopes constantly scanning the sky specifically to catch objects like this early, astronomers expect interstellar visitors to be detected more frequently in the coming years, not less. Each one will carry its own chemical fingerprint from wherever it originally formed. Each one will offer a brief, unrepeatable window to study material from beyond our own solar system. And each time, James Webb, or whatever telescope succeeds it, will likely be asked to interrupt its schedule once again, chasing a visitor that will not wait for anyone. If stories like this genuinely fascinate you, the mix of real, published science, and the sheer scale of what's actually out there, make sure you're subscribed to this channel, because we'll be covering the next interstellar object the moment it's confirmed. So here's the real question worth sitting with. An object shaped by conditions in a solar system we will never visit, carrying chemistry unlike anything found near our own sun, just passed through our neighborhood and is now gone. continuing on a journey that will likely outlast human civilization itself. What do you think that unusual carbon dioxide signature is actually telling us about the star system it came from? Was it formed somewhere unusually cold, unusually radiated, or somewhere entirely different from anything we've modeled before? Drop your theory in the comments below, because researchers themselves are still debating the answer. And if this story pulled you in the way it pulled me in while putting it together, hit that like button. It genuinely helps this channel keep bringing you stories like this one, straight from the front lines of active scientific research. There's another layer to this story that doesn't get talked about enough, and it has to do with timing. Discovering an interstellar object at all requires an enormous amount of luck. These things are small, faint, and moving fast. And for most of history, we simply did not have the technology to spot one before it had already passed us by. The fact that we caught 3 of them in less than a decade, Oumuamua in 2017, Borisov in 2019, and now 3I Atlas, suggests these objects are far more common than anyone previously assumed. They've likely been passing through our solar system for as long as it has existed. We just never had the tools to notice. That changes the entire conversation. If interstellar visitors are common rather than rare, then every star system in the galaxy is constantly leaking material outward, sending fragments of itself drifting silently between the stars, occasionally wandering into someone else's solar system millions of years later. Multiply that across the roughly 200 billion stars in the Milky Way alone, and you start to understand the scale of what astronomers are really grappling with here. Our galaxy may be filled with an almost uncountable number of these wandering fragments, each one carrying a tiny frozen record of wherever it came from, most of them destined to drift forever without ever being observed by anyone. That's part of why the data from James Webb matters so much beyond just this one comet. Every chemical signature captured from 3I Atlas becomes a reference point for the next object we find, and the one after that, slowly building a library of what interstellar material actually looks like across different origins. Right now, that library has exactly 3 entries. Within a few decades, as detection technology continues to improve, it could have dozens, giving scientists an entirely new way to study the diversity of planetary systems across the galaxy without ever having to leave our own. It's worth remembering just how young this entire field of study actually is. The first confirmed interstellar object was only detected in 2017. That means everything we currently know about visitors from other star systems has been learned within less than a decade, almost entirely within the professional lifetime of scientists working right now. Every observation, every spectrograph reading, every chemical anomaly is genuinely new territory without decades of prior data to compare it against. That's part of why the scientific community reacted the way it did when 3I Atlas showed up. Nobody had a complete rulebook for what to expect, because the rulebook is still being written in real time, one interstellar visitor at a time. Somewhere out past the orbit of Jupiter right now, 3I Atlas is still moving, carrying its ancient chemistry back into the dark, on a journey that began before humans existed and will continue long after we're gone. 1 minute ago, James Webb caught its final signal. It may be a very long time before anything like it passes our way again.